Welcome to this explainer. Today, we're going to build a bulletproof learning system from the ground up by looking at the hard science of accelerated learning. If you've ever spent hours just staring at a textbook or a screen, only to completely blank out the very next day, you're definitely not alone. We're going to decode decades of research to show you exactly how to lock information into your brain permanently.
So let's tackle this massive problem right out of the gate. Back in 1885, a German psychologist named Hermann Ebbinghaus discovered this through some pretty intense self-experimentation. He found what we now call the forgetting curve. Basically, without active intervention, we forget roughly 70% of new information within a single day. Think about that for a second. You spend 3 hours studying, and by tomorrow, over 2 hours of that effort have literally vanished. It's like trying to fill a bucket that has a giant hole right in the bottom.
And this brings us to our biggest enemy when trying to learn, the illusion of knowledge. We read a page, we highlight a paragraph, we nod along to a lecture, and our brain is like, yep, I recognize this, I totally know this. But as Mortimer Adler points out perfectly here, if you can't express it from your own mind, you don't actually know it. That feeling of familiarity, it's just a mental trick. It's passive recognition, not active mastery.
Okay, here's how we're going to construct our learning house today. First, the illusion of learning. Second, building our foundation with the Feynman Technique. Third, retrieval through the testing effect. Fourth, retention using spaced repetition algorithms. And finally, number 5, we'll wrap up with the Modern Learner's Toolkit.
Let's start with section 1, the illusion of learning, which is essentially the antidote to cramming. Now, what's really fascinating here is the stark contrast between the illusion of passive studying and the reality of actual active mastery. We usually rely on passive repetition, right? Just rereading notes over and over. But way back in 1620, Francis Bacon noted that if you read a piece of text 20 times, you won't learn it nearly as well as if you read it 10 times while attempting to actively recite it from memory. Active retrieval forces your brain to actually work, creating real neural pathways instead of just skimming over familiar territory.
Moving right along to section 2, let's build our foundation with the Feynman Technique for deep understanding.
Nobel laureate Richard Feynman hit the nail on the head here. He realized that complexity and jargon usually just mask a total lack of understanding. Seriously, if you find yourself using big buzzwords to explain a concept, it usually means you're hiding behind those words because you don't grasp the core essence of the material. To combat this, he developed a foolproof 4-step method. The whole point is this: if you can't explain your topic to a child, you need to go back to the source. Step 1, take a blank page and map out everything you know. Step 2, write out your explanation using words a 12-year-old would easily understand. Step 3, when you inevitably hit a wall and get confused, which, let's be honest, you will, that clear writing reveals the exact gap in your knowledge. That's when you go back to the source to review and refine. And finally, step 4, test your understanding by actually teaching it to someone else without looking at your notes. All right, on to section 3, retrieval and the testing effect. Time to frame the house. Here's the thing about testing. It isn't just an assessment tool for grades. It's actually a highly effective teaching tool that creates multiple retrieval routes for your memory. Often called active recall, this principle proves that the very act of trying to remember something alters the way your brain stores that information. Cognitive psychologists have shown over and over that testing your prior knowledge is just way more beneficial than passively restudying the material. What this means in practice is that the harder it is for your brain to remember something in the moment, the more likely you are to actually retain it for the long haul. We call this desirable difficulty. It's literally like lifting weights at the gym. If you lift a 1-pound weight, your muscles aren't going to grow because there's no strain, right? If you struggle to recall a fact, that mental friction is exactly what signals your brain to strengthen that connection. And get this, even if you get the answer wrong, the effort of trying to retrieve it makes the subsequent learning much, much stronger. So how does this look today? Well, students on Reddit are practically applying this science right now, using AI tools like Google Gemini for guided active recall. Instead of just passively reading a PDF, they upload their materials and prompt the AI to become an interactive tutor. But the real secret to making this work is strict prompting. You have to tell the AI to go in sequential order, pause, and force you to retrieve the information it just taught you, without jumping ahead to concepts you haven't seen yet. It completely transforms passive reading into a desirable difficulty workout. Okay, section 4, retention through spaced repetition algorithms. Let's put the roof on our learning house. Spaced repetition has evolved massively over the last century. The core idea is testing yourself on a piece of info at the exact moment your brain is about to forget it.
Back in the 70s, Sebastian Leitner did this by physically moving paper flashcards between different shoeboxes. Then, in the late 80s, the SM2 algorithm came along and powered digital flashcards for decades. But the real breakthrough? That happened recently in 2022 with the release of the open-source FSRS algorithm.
This modern FSRS algorithm completely changes the game. It works by tracking difficulty, stability, and retrievability in a way that is entirely unique to your own brain. The older SM2 system was rigid. It basically gave everyone the exact same math out of the box. But FSRS fits a highly personalized statistical model to your actual review history. It learns which specific cards you find hard and how quickly your personal memory decays. And then it adjusts. You can literally tell it, I want a 90% retention rate, and it mathematically plots your exact study schedule to hit that target.
And the results of that personalization are absolutely huge. By switching from the old SM2 algorithm to FSRS, you can achieve the exact same retention rate while doing up to 30% fewer flashcard reviews. When they tested this on over 500 million reviews, the data showed a massive jump in efficiency. I mean, if you're studying thousands of items, that translates to hours of your life saved every single week just by upgrading the math running in the background. Let's move to our final pillar, Section 5, the Modern Learner's Toolkit, and get you equipped. As you'll hear from university learning centers everywhere, choosing a dedicated spaced repetition app is absolutely essential because it automates those ideal spacing intervals for you. Doing this manually on paper works in theory, but if your reviews aren't perfectly regular, the sheer volume of cards will become completely overwhelming very fast. So looking at the options available today, finding an app powered by FSRS like StudyGlen or Anki is the absolute best default for your long-term memory. Let's break this down real quick. If you want zero setup and want AI to instantly generate cards from your PDFs, StudyGlen uses FSRS by default. If you're a power user or med student wanting total offline control, Anki is the undisputed king and made FSRS its default back in 2023. If you're a heavy note taker and want flashcards built right into your notes, RemNote is great, though its default is still the older SM2. Brainscape offers expertly curated decks using a proprietary system, and then there's Quizlet, which has a massive library, but honestly, it really only uses a basic Leitner-style system that isn't ideal for true long-term spaced repetition. All right, we've given you the complete blueprint to defeat the illusion of learning. The only question left is, how are you going to put this toolkit to work for you today? Are you going to start testing yourself instead of just happily highlighting your notes? Will you try explaining a complex topic to a 12-year-old? Or maybe you'll download an FSRS-powered app and start mathematically locking that knowledge into your brain? The science is clear, the tools are free, and your accelerated learning journey starts right now. Thanks for joining me on this explainer, and happy studying.